Okay, so that's the approximate probability for the chance for x equals 20. Okay, so the approximate probability is 0.0377. Okay, so this will, if we did it correctly, this will be somewhere close to this. It'll be somewhere close to that. So it won't be exactly, but yeah, it should be close enough. All right. Okay, let's look at part B now. Okay, part B is saying find the probability of x being greater than or equal to 20. Okay, now I'll start off again from the binomial perspective. So if you do this binomially, we'll have to go 50 choose 20, 0.3 to the 20, 0.7 to the 30. Okay, so that's the starting off point, but we'll have to keep going and go, it's greater than or equal to, so we had to go 50 choose 21, 0.3 to the 21, 0.7 to the 29, right? And then I have to add up more terms, 50 choose 22, and then so on, all the way up to 50 choose 50 of 0.3 to the 50, 0.7 to the 0. Okay, so we have to go all the way. So there's a lot of terms to add up, right? So I guess that's another reason why you would want to do normal distribution. So you would have what 31 terms to add up, right? Or you can simply approximate this to a normal distribution. So let's draw the normal distribution first. So what they're asking you to do is find this. So again, if I draw the that's 20 right in the middle. Okay, they want you to find 20 and beyond, including 20 and beyond, all the way up to 50. Okay, but remember there's approximations, so it'll be, we'll have to do something. Okay, so the question is, do I choose 20.5 or 19.5? That's a big question, right? You cannot start from 20. You cannot start from 20 because why do you ask? Because you're going to miss out on this area. If you choose start from 20, we're going to miss out this area, this green area. Okay, but so we need to include that. If we want to include that, what we need to do is okay, so if we want to include that little area, we actually have to start off from 19.5. Okay, so the probability of x greater than or equal to 20 is approximately equal to probability of x greater than 19.5 when we talk about normal distributions. All right. So my little thumb rule is to ask yourself if it's greater than or equal to 20, right? So which is this side, right? In a way, you can think the arrow points which way you need to color in. Okay, so that's one way of thinking about it. If that's the case, if I choose 20.5, will it include my 20? So if I choose 20.5, will it include my 20? So if I had put 20.5, as you can see, as soon as I put greater than 20.5, it doesn't include my 20. So I actually have, so 19.5 is the logical choice. All right. If I asked you the question, x is less than or equal to 20, right? If I chose 19.5, remember I'm coloring this way now. If I chose 19.5, will it include my 20? It won't, right? So in this case, it would be x is less than 20.5. In the normal distribution, it doesn't really matter if you put the equal sign or not. Okay. If it makes you feel comfortable, sure, go for it. All right. So that's what you do. If it includes the value that you're looking for, that's how you choose which 0.5 to take. All right. So coming back to this question, probability of x greater than 19.5 is equal to, in the z domain, probability of z being greater than or equal to 19.5 minus 15 divided by 3.24. Okay, so this is probability of z greater than or equal to 1.39. Okay. Okay, so in this case, if it's 1.39, remember in your, again coming back to the standard normal distribution, if you go back to the shape, they give you the left tail, they don't give you the right tail. But what we're after is everything on this side, right? So that's what we're after. But what they give you is everything on this side. So how do I find this yellow area? Simple. I simply find this area first and go 1 minus that. All right. So that area I know from my previous question, that is 0.9177. So this area is simply going to be 1 minus 0.9177. Okay, so our final answer for this question is going to be 0.0823. Okay, now, okay, so we're almost done. It's the last question, and that is probability of x greater than 20. Now, if you jump into this question and go, it's the same as the previous question, you'll be wrong. Because what you need to realize is that this is saying, this is equivalent to saying x is greater than or equal to 21. Okay, so be careful with this just a greater than sign. If it's just a greater than sign, you need to convert it into a greater than or equal to sign and then do the question. Okay, so this is approximately equal to x greater than or equal to 20.5. We're talking about normal distributions, and this is the same as probably z greater than or equal to 1.7. Okay, which is simply going to be 1 minus 0.9554. Okay, so this bit should be fairly straightforward to you by now. 0.0446. Okay, sorry about my bad handwriting, but anyway, so these are your solutions. 0.0823 the previous question, 0.0446 for this one. So yeah, if you have any questions regarding what we've done, just leave any comments. Please rate it, give me any feedback. Would really appreciate it, and thank you.